Welcome. So in this video, we're going to be answering this question, which says, consider the function f of x is equal to x plus 3 squared plus 2. The first thing we need to do is state the largest restricted domain of f of x such that the inverse of f exists and is worth 1 mark. What we need to realize is that in order for my inverse function to exist, what needs to happen is that my function, so my original function, needs to be 1-to-1. So that's the implicit question being asked here. What it's really saying is restrict my function so that it's 1-to-1. Because we know if our original function is 1-to-1, then I will have an inverse. My inverse will exist. To find what this is going to be, I'm going to take my original function here. I'm just going to give it a sketch. So I'm going to take this. X plus 3 squared means I'm going this way, -3. I'm going 2 up. It's going to be here. I've got this part of it, and I've got this part of it. Whoa, that's ugly. Let's try that again. That part of it right here. All right, let's pretend that looks good. Actually, let me try one more time. There we go. Now, in order for this to be 1-to-1, it has to pass the horizontal line test, which means if I draw a horizontal line, it'll only touch it once. At the moment, you can clearly see that it's touching it twice, so it's not working. So I've got two ways that I could have the largest restricted domain for this to be 1-to-1. I could either choose this part of the graph, or I could choose this part of the graph. I can't have both. So what I'm going to do is I'm going to show you both options. So option 1 would be just considering this. So option 1 would be x is an element of -3 to infinity. Remember, you're after the largest restricted domain, so that means you have to include -3 in order for it to be the largest. Or your other option, option 2, would be, instead of considering this part of it, you consider this part of it. That is horrible. You're considering that part of the graph. Let's just pretend that looks good. In which case, you would be getting x is an element of -infinity to -3 and including it. So those are your two options. For the remainder of this question, I'm just going to be considering option 1. So just that right there. So for the remainder of this video, I'm just going to be considering option 1, in which our domain is from -3 to infinity. Okay, so those are your two options for A. The next thing that we need to do is B. So using the restricted domain of A, find the equation of the function, the inverse of f. So we're just finding our inverse function here is worth 2 marks. So that means we're going to get 1 mark for working and then 1 mark for our final answer. So in order to do this, what I'm going to first do is let y equal f of x. So I can write it as y is equal to, and then just this right here, x plus 3 squared plus 2. And then remember, what you're going to do is swap your x's and y's. That's how you find the inverse. So I'm going to do that now. And then your next step is to get y by itself. So I'm going to subtract 2 from both sides, y plus 3 squared. Then I'm going to square root both sides to get rid of the square. So I'm going to get plus or minus the square root of x minus 2 is equal to y plus 3. I then am going to subtract 3 from both sides. So minus 3 plus or minus the square root of x minus 2 is equal to y. Perfect. So let's now just rewrite what we've found so far. This isn't our final answer. Y is equal to -3 plus or minus the square root of x minus 2. Now, let me pause here for a moment and say that many people would just stop here and leave this as their final answer. Now, the reason why this isn't your final answer is because you can't leave it as plus or minus. It's either one or the other. You can't leave it as both. You need to figure out which it is. And the way you figure out which it is by considering the domain. And that's why this question says use the restricted domain of A. So we're going to use our domain of the function to figure out what it's going to be, what my inverse is going to be. Is it going to be plus or is it going to be minus? Now, let's just draw ourselves a little graph of what we've found so far. So what does this look like? Well, it's a square root graph. I'm going down 3, I'm going this way 2. I've got a positive section, so this is the positive part of the graph, and this is the negative part of the graph. And we need to figure out which side am I taking. Well, if I know that the domain of the function is -3 to infinity, that means the range of the inverse is going to be -3 to infinity. Because remember, the domain and range swap when you find the inverse. They swap. So that means if the range of the inverse is -3 to infinity, well, -3 to infinity is just the top part of it. So it's very important for you to realize that the domain and range swap from the function to the inverse. And by using that, you can figure out whether it's going to be plus or minus when you have a square root as the inverse. So that means my final answer is going to be this. So the inverse is going to be -3 plus the square root of x minus 2. That's going to be my answer, not plus or minus. It's one or the other. So you use the domain of the function to figure it out. That's what my answer is going to be. Perfect. Let's now come to the final part of this question, which is C, which says sketch f of x using the restricted domain found in part A, and on the same axes, sketch the inverse function found in part B, label all axial intercepts and endpoints. As you can see, it's worth quite a few marks, and that's because we have to make sure that we're labeling all our axial intercepts and endpoints, so make sure that you're doing that. Okay, so let's now get to work. The first thing that I'm going to do is just consider what my original function was. It was, what was it? It was x plus 3 squared plus 2. So I come over here. I'm going to go this way, -3. I'm going to go up 2. It's going to be here. And remember, I'm only considering this part of my graph. And let me see if I can draw that a bit nicer. Actually, let me just draw this a bit further down. That. Perfect. So remember that restricted domain. So you're not drawing the whole thing. Many people like drawing the whole thing, but remember, we've got a restricted domain here. Make sure the graph looks good. Perfect. I have to label my endpoint. So I have to label this as -3, 2. And as you can see, I have a y-intercept. I need to find what that is going to be. And to find what that is going to be, I'm going to let x equal 0. So I'm going to get y is equal to 3 squared plus 2. Y is equal to 9 plus 2, which is 11. Which means this is going to be 0, 11. It's also important that you just label what this is, so just call it f of x. So as you can see, I've got my endpoint, I've got my y-intercept, and I've labeled it as f of x. If we now come to our inverse, remember our inverse was -3 plus the square root of x minus 2. So that means I'm going -3 down, I'm going 2 across, so it's going to be about here, and then it's just the positive part of it, so it's going to look something like this. Please draw it neater than I draw it. Perfect. It's going to look something like that, and hopefully you can just see by looking at this, because remember the inverse means it's reflected across y equals x, that this right here is simply going to be -11, 0. Sorry, not -11. It's going to be 11, 0. This right here is going to be 2, -3. So as you can see, they've just swapped around. My x and y have swapped, my x and y have swapped. But if you were struggling to see that, you could still find what this is going to be by letting y equal 0. So you're finding the x-intercept by letting y equal 0, in which case you're going to get 0 is equal to -3 plus the square root of x minus 2. I'm going to get 3 on this side, x minus 2, whoa. Then I square it, 9 equals x minus 2, x is equal to 11. And just like that, I found that x is equal to 11, or you could just recognize the swapping over of these. Also make sure you label this, like so, and there you go. So as you can see, I've labeled my axial intercepts here and here. I've labeled my endpoints. I've labeled both graphs, so it's all very clear. Everything is written as coordinates, which is the custom. And yeah, that's how you would approach these types of questions. So a really big takeaway, make sure that you are using the restricted domain when you're graphing. Make sure you're labeling the axial intercepts and the endpoints. Make sure you're labeling what each of the graphs are. And then when you're finding the inverse, make sure you don't leave it as plus or minus. And just be very careful, use sketching if appropriate to help you find those answers. But hopefully you found this useful in getting all your answers here. And yes, we'll leave it there. Hopefully you found this helpful. Bye-bye.